I'm Anil Kumar sharing with you few graphs on trigonometric functions. Let me thank Ritesh for making this request. Once again, I'll request all the subscribers and the viewers to also send me an email with their names so that I know exactly who's asking which questions, and it helps me to provide a personalized solution for their questions. So Ritesh, you wanted to understand how to sketch graphs of few trigonometric functions, and you just wrote few examples. I copied them. And now let's look into it. So basically we have two categories here. One, we are working on the sine graphs and one on cosine graphs. So let's talk about the cosine function first. I'm going to make very rough sketch, right? So I'll draw let's say two periods for each function. Okay, so here is the cosine basic function. So we should always start with the parent function, which is cos of x. Now cos of x is maximum at 0. So basically it is between plus and minus 1. So these lines which I'm just sketching here are guidelines for me to show that the range of cosine function is between plus and minus 1. Right, so that is what it is. Now basically the cos function starts with the maximum, right? So we could go like this and then it is like this, right? So cosine and sine functions are kind of related since they are 90 degrees phase shift or pi by 2 phase shift. So that becomes a cosine wave since it starts with a maximum. Now time period for cosine wave is 2 pi. So it starts with 0, that is 2 pi. So these are pi by 2 intervals. So pi by 2, 2 pi by 2, this is 3 pi by 2, right? So let me write 3 pi by 2. So that's your cosine function, right? So this is the starting of one wave, ending of that. Now when I have cos of 2x, then what happens? For cos of 2x, the time period becomes half, right? So there are two cosine functions, two waves within 2 pi. So the time period here is equal to 2 pi by 2, which is pi, right? So remember, we are talking about pi, which is 180 degrees, right? So you could always write 2 pi as 360 degrees, pi as 180 degrees, and when we say pi by 2, we mean 90 degrees, correct? So those who are working only in degrees, for them, that is how they are related. Now let us see how to sketch the cosine function when it is compressed, right? So let's see that part. Now what basically happens is, this is your one cosine wave. So these are four different parts, basically positions in 4 quadrants. Is that okay? Now these are your 4 different parts. What really happens is, when we say cos of 2x, then we have 2 waves within this period instead of 1. So it gets compressed. So cos of 2x really means compressed horizontally by a factor of 2, right? So it gets squeezed in. So like 2 waves will come within this period, right? So basically what you will notice here is that from, let's say, that is the maximum value and this is the minimum value, right? So we'll have one wave starting from here and ending this place, right? So we have one wave starting from there and ending there, right? This is one wave, and the other wave starting from there and ending there. So that becomes cos of 2x. Do you see that part? Do you understand? So within 0 to 2 pi, or you can say 360 degrees, let me write 360 degrees. Now we have 2 waves. So 2 cosine waves are here. So that is cos 2x. Now how do I sketch cos x plus 45? So I think first part is clear, right? Now let's do cos x plus 45. This means it is translated 45 degrees left. That is the translation. So every point actually shifts 45 degrees left, right? So the second graph for you, where, let me sketch the cosine function now here, dotted line, let's say, right? So let's say this is our cosine function, right? Okay, so this is our cosine function, which is from 0 to, let's say this is 2 pi. 45 degrees, I should write 0 to 360 degrees. Okay, so that means this is 180 degrees, right? And this is 90 degrees. Perfect. So half of 90 is 45. So every point will move half unit, right? So that is 45. So every point is going to move half unit to left, right? So that is the transformation, right? So instead of starting from 0, the maximum value being at 0, it is going to be at minus 45 degrees. So the graph could now be, let me just make this 2. So I'm making a rough sketch here again. So it will shift. The time period remains same, right? So the time period remains same, but the so basically what happened? So this moved, there's something wrong here. So basically this point has to come here, right? So this point has to come here, and that is how it is, right? So I think something went wrong. This is how the curve is going to be. So let me sketch this in darker color so that it's absolutely clear. So everything just moves by pi by 4, or right. So that becomes your wave. So one full wave has been shifted by 45 degrees to the left, right? That is what is meant when we say cos x plus 45. Is it okay? So just shift each point by 45 degrees. So what do you have to do here? Draw the original graph and then shift it, right? So push it right this side. Okay? And then you connect these points. Then you connect these points. Do you get this graph? So this graph represents cos of x plus 45 degrees. Is that clear, right? That's what I tried to do here. Now, let's look into these sine functions. We'll draw them here. You know what sine wave is. So what I will do here is I'll straight away draw sin 4x. So basically, we'll actually sketch one sine wave. Now these sine waves have amplitude of 1 only, right? They are being translated horizontally, compressed by a factor of 1/4. So the wave here for sin 4x will be kind of like this. Right. So when we have sin 4x, it means what? Sin 4x means that within one time period of sin x, there will be 4 waves. So count from where? 1 wave, then you get 2 wave, then you get 3 wave, and then you get 4 waves. So I should have completed, right? So that is within this period, right? So let's do like this. So we have a time period of 2 pi within which we have 4 waves. Do you see that? Right? So the time period of one wave is 1/4 of 2 pi, that is pi by 2. So here the time period is equals to 2 pi by 4 or pi by 2, right? Or in degrees, you can say 90 degrees. Doesn't make sense. So sine of 4x is basically a sine wave compressed horizontally by a factor of 1 over 4, right? That is what it is. Now minus sine 2x should be what? Now I hope you understand all these concepts. You can actually pause the video, sketch it yourself, and then check with my solution, right? So minus of sine 2x really means that instead of starting and going positive, it will go negative, right? So minus, that is reflection on the x-axis, correct? So this time the wave will kind of go like this. Let me draw those lines at plus and minus 1 to complete this drawing. Well, on a graph paper, you could get fairly good results. So here is your sine 2x. So now within 0 to 2 pi, we'll get two waves. So this is one wave, right? Repeating, and that's the second. So that is your 2 pi. This is your pi. So time period for sine 2x is going to be pi. So this is your sine 2x. Now in this case, time period is pi or 180 degrees, right? So you can write 180 degrees if you want to. And it goes from plus 1 to minus 1. So all these, whichever I've sketched here, they are between plus and minus 1, since in our case, we did not take any vertical stretch or compression. Does it make sense to you? So this is minus of sine 2x, right? Going negative. That's how it is. So I hope that makes sense. Feel free to write your comments, share your views, and share my videos with your friends. If you have more questions, don't hesitate. Thanks for participation. All the best.